few words. Assalamu alaikum, everyone, and good afternoon. We have a very distinguished person with us today, Basel Mahfouz. Basel Mahfouz is a visiting fellow at Harvard Growth Lab, where he conducts interdisciplinary research on the relationship between scientific research, technological growth, and economic complexity. He is currently pursuing a PhD in Science, Technology, Engineering, and Public Policy at the University College London, UCL. Basel earned a master's in Environmental Technology from Imperial College London. He utilizes cutting-edge computational tools and methods to develop a new framework for measuring the societal impact of scientific research. Basel is a staunch believer in the power of crowdsourcing to invite people to collectively contribute to public policy solutions. Prior to starting a PhD, he co-founded SynSapien, which was a platform for crowdsourcing. He has written extensively on how such innovative policies can be helpful to finding policy solutions. With such a dynamic and interesting portfolio of research interests that spans from environment to innovation in policy designs and from machine learning to AI tools for societal problems, we are very glad to have Basel with us today. So I request Basel to please let us know a little more about his interests and work, particularly about how he sees the interaction between environment, innovation, and policy. So over to you, Basel.
Thank you so much, Masood, for the intro and also for hosting me here today. I guess as an overview, I'm a computational social scientist. So essentially, I look at how we could use the latest in machine learning, AI, or essentially computational tools for addressing societal problems. The problem I'm trying to solve now is the one about the use of science in policy. So I'm going to share my slides now and dive straight in. Right, so the title of the talk is kind of looking at machine learning methods, but I use the term machine learning very broadly. So you will see that because I don't want to also kind of put a barrier. You could use very simple machine learning models in a lot of tasks, and I will show you today how that can be done in different applications. But so the talk today will be about applying these machine learning models for analyzing the use of science and policy. So we have governments around the world, and they are trying to solve critical challenges. And a lot of the times, they need to use and leverage existing scientific knowledge, whether in universities or in papers published around the world. And so we want to understand this particular dynamic. Not to delve into the history, but an interesting context here is that we have, over the past 30 years, a transition in science. So whenever research was funded, it was required to only be excellent, right? You just kind of proposed a research project and it would get funded based on its merits as a research as a researcher, as its academic excellence. However, we see now a gradual shift and a bigger demand where it's not just enough to conduct excellent science. Your science also has to have an impact on the world. So we see that originally with research funders requiring something like a statement about the societal relevance or about the potential applications of that research in real world in real world settings, all the way to now where it's become actually institutionalized, and universities, for example, in the United Kingdom and in Europe, are evaluated based on the impact that their research has on society, and it has an effect on the funding or the funding they receive from funders. So let's look a little bit about what that impact looks like. So this is, for example, an extract from the Research Excellence Framework, so the evaluation they use in the UK to assess universities on their societal impact. And we see there's all sorts of different aspects that universities can demonstrate or scientists can demonstrate when talking about the impact of their work. But one of the things, you see on the right side, actually the first one on the impact categories is policy and public services. And it's a very important one. So science is supposed to, or at least now is encouraged to, have real societal impact on policies and on the delivery of public services. And this is where this research is focused on, that intersection between policy and science. But if we're going to track how science is used in policy, we need to have an understanding about, about the relationship that already exists. And the problem is that it's a bad relationship, so to speak. It's across the literature you can look, and there's been countless studies that have been done, and most of them tend to point to the same problem. And the problem is that there's a gap. Science works one way and government works another way. And there's a lot of issues in trying to kind of connect the two together. I'm not going to delve into all the reasons outlined. I'll maybe say a few of them. Some of the barriers, for example, include mixed timelines. Science is slow. It takes time to get funding. It takes time to conduct research. It takes time to publish, and then it takes time to share those research publications with the world. But policy is a little bit more quick, or has a different timeline for trying to get legislation through. And more importantly, these two timelines don't necessarily mix or interact very well with each other. Another one is a very simple one. Researchers publish academic papers that are put into all these different, usually for payment services, so to access them. And policymakers don't have subscriptions sometimes to these libraries or to these tools. So a lot of times they simply can't access the science unless it's published as open access. So there's a whole range of reasons why science struggles, or policy struggles, to absorb science or use science, and vice versa, how scientists struggle to get their work recognized by policymakers. I would so while most of this research has been qualitative, so it's been done using kind of case studies or interviews or different surveys, there's been a push towards using this research or trying to use computational methods to do this research. And it's largely because we finally have the data, first, and two, we have the kind of capabilities in the last few years. So the data that we have on the one hand, so we have pretty much a lot of bibliometric data available to us. So there are private sources that provide this data. For example, Elsevier through Scopus, which funds my research and provides me with this data, has about 90 million research papers. It's got its abstracts, the authors, the metadata, all that is available for analysis. But there's also open source ones like OpenAlex, which you could use and gets, has a similar, or at least a different format for the data. All this data essentially is public domain in a way, but at least how you access it, interact, and how it's organized and cleaned is provided by these services. And on the other hand, there's now new data sources about policy documents. So for example, Overton indexes policy documents. There's about 15 million policy documents the last time I checked. And they also capture the science that is cited or referenced within those policy documents. So some of the first research that came out, such as these two great papers, one of them was in Nature and the other one was in Science, which tried to start using these tools to analyze the relationship between science and policy. And interestingly, what they kind of started seeing is a difference between the kind of disconnect, what was being promoted by the kind of qualitative research, and the quantitative side, where they said, actually, science, policymakers are using good quality science, and but there's a difference between organizations, between domains, so it's a bit of a nuanced relationship. So this is where I wanted to zoom in. I wanted to understand this kind of disconnect or this disagreement between the gap that exists on one hand as being documented by the policy aspects, and then this new quantitative findings that actually, hey, good quality research is making its way to science. So what I did was very simply tried to look at the difference in metrics between what is cited in government policy and what is not. So this is called a field-weighted citation index. It's very simple. When you publish a paper in science, is your paper cited by other scientists more or less than average in your field? So if it's above average, if it's above 1, then you're doing well. Your paper's getting recognition. If it's below 1, then it's not doing so well, or less. It's doing less well compared to your peers. So we see on the orange one are the papers that are cited in policy, and the blue one is papers that aren't cited in policy. So on average, in general, if we take like a zoom out look, it's true. The findings of the previous papers are very true. The papers that are cited in policy tend to be higher quality, or it's a
I'm
proxy.
sorry, Basil, can I disturb you for a minute? Are you moving your slides? We are only able to see one slide.
Yes, I'm on slide 6. Oh, that's
No,
something.
no, no.
All right, so this is where we are
I
now. So
thought
thank you
I
for
thought
just
this. No problem.
all right, thank you for letting me know. Yes, good. So sorry about that. You didn't miss much of these slides, but this one's probably a good one to zoom
Okay,
in on.
you covered that in your talk.
Yes. So Yeah, so the orange ones you can see kind of the higher distribution, right? So the papers that are cited in policy are better quality. And or more are cited more on average compared to their peers in their field. Similarly, this is a framework called the H index. So it looks at the authors. So a higher H index means the author has published more papers and has been cited more in their field compared to a lower H index. And again, we see generally that the papers cited in policy, so the ones in orange, tend to come from authors that are of, have published more papers and have had their papers cited more by other authors, by other scientists. Site score is a journal level metric. So this one is if you're publishing in a higher or lower impact journal. And here it's a little bit more mixed. So you can see generally, yes, the average is a bit higher for papers cited in policy, but it's not very conclusive. So what I wanted to understand is, given these three metrics how well do they explain when something gets cited in policy? So in a machine learning sense, we want to say, if I trained a machine learning model only on these metrics, only on these kind of quality metrics, what is the likelihood, or to what extent will the machine learning model be able to predict whether a paper is cited in policy or not, right? So here's the kind of architecture of the basic model here. So we took 16 million research papers. They're classified into the different sustainable development goals that the United Nations has set, right? So for each paper, we know generally if it addresses one of these 16 topics. We took these three metrics that I talked about before, but I also added a fourth metric, which is called mentions, which is the number of times this paper appeared in the news or in social media, basically the number of times it had kind of like soft alt metrics. We took all these parameters and put them into a logistic regression. So logistic regression is as basic a machine learning model as you can get, right? It's learning from the data, but it's essentially still just a regression. And then we told the logistic regression, hey, based on this information, if I give you a paper with certain parameters, can you predict correctly which paper is cited in policy or which paper is not cited in policy? And then compare those against random chance. So if I were to randomly select a paper from the batch, will this model do better? So that was the test that we conducted for this policy. And you can see here the distributions of the number of papers cited in policy. And this is important because this is the benchmark, right? So when we said random chance, it's not 50-50. It's the percentage of papers cited in policy. So for SDG 3, good health and well-being, the orange part is the number of papers cited in policy, and the blue ones are the papers that are published but not cited in policy. So when I pick one at random, I'm more likely to get a paper not cited in policy than a paper cited in policy. So keep in mind that it's a very low benchmark. I'm asking it to predict above that threshold, not on a 50-50 basis. So this is what we got. So what we got is, for the most part, none of the models were able to predict if a paper would be cited in policy, only based on the quality parameters that we set, which means that these metrics generally don't explain why something gets cited in policy. It's not enough, right? So even though they are higher quality, or they tend to have these metrics in a higher number, they do not explain why something is cited or not cited in policy. But we also see there's a variation. So in some fields, it's actually a bit closer to the line. So the line, the dotted line in the middle, this is the random choice, or the random choice model for that field. And the red bar, the further away it is from that line, the worse it performed compared to random choice. So the best model we had was for no poverty, so SDG 1 no poverty related papers. And the worst performing one was for affordable and clean energy. So for example, so how we'd interpret that is, in number 7, quality metrics played pretty much no role in determining when something gets cited or not cited in policy, and 1, it did better, but still below that threshold. You're better off just selecting a paper at random. So this is just kind of showing the different weights and the different aspects of this. So just to kind of show that between the different metrics that we chose, more it was actually the field weighted citation index more than the other ones. So paper level metrics, so how often your paper is used by other researchers, that tended to play a bigger role. But again, all of these were negligible because essentially the test, or the model failed. So this is another way to kind of visualize it. So you can see the red is the more weight it's given to a certain parameter. But you can see that even though the field weighted citation index across the board tended to play a bigger role in policy impact than the other ones, it was actually a mixed bag because in some other fields, it had a different weighting. So it's actually quite interesting to see how these different parameters play per field. What I interpret from this is that different fields interact with science differently. So it's a very basic statement to say, but at least now we have some data to show it. What do we learn from this study? First is that having academic impact does not mean you will have policy impact. And that's actually a very important lesson because the whole academic system is based on these parameters. Publish more papers in better journals, publish and get them cited more by others. If you do that, if you play that game and you follow those rules, it doesn't mean you're going to get cited in policy. Something else determines what puts you in policy or doesn't. And it's actually an incentive problem for universities because if we actually now are pushing universities to have public policy, to have impact, and universities are determining who gets funding and who gets support based on that impact, then we need to fix how we incentivize scientists, how we incentivize researchers. But ultimately, we still don't have an answer. What determines policy impact, right? Because if it's not these factors that we tested, what is it? So I just want to say that even though it's an interesting model, this was my first attempt at this. So obviously I don't want to say mistakes, but it was a steep learning curve. It was my first paper. So in that learning curve, you have to understand that the data itself is not equally structured, right? So here is the breakdown of research papers and the number of papers cited in policy by country within the SDGs. And you'll notice that even though we're saying this is a global aspect, but for the most part, it's the US that accounts for the vast majority of the papers that are published and the papers that are cited. And this is not just because the US publishes a lot of papers, it's also because we're able to track US policy documents or UK policy documents or EU policy documents better. So there are within the databases biases that affect this outcome. And that is that, if I have more US policy documents, more likely they're citing US research. So if I don't have Pakistani policy documents, I might not be capturing Pakistani research. So it's important to keep those limitations of the data structure in mind. But most importantly, I think I came across this paper and it really kind of shocked me because what this paper is showing is that the mapping methodology of matching a paper to an SDG differs. There's different ways to do it, right? I use something that was developed by Elsevier, but there's other there's other matching approaches that took a paper and decided, well, does it belong to SDG 7? Does it belong to SDG 6? And what this paper showed was that if you use different methodologies, you get fundamentally different results. And that's a big problem because how can we infer anything from this data if something as fundamental as classifying the papers into the correct SDG can result in very big differences? And that is kind of the crisis point within my PhD because I said, hey, we need a better way. We need a better way to determine or to filter out and make sure that we're studying the right data and the right approach. And this brought me to the second paper. The second paper moves from using the SDGs as a framework to a different framework. And I'll say why I chose the SDGs in the beginning. For the most part, SDG research is addressing a policy issue. So it should be more relevant to policymakers. So I assumed that by a paper, by virtue of being into the SDG, by virtue of it being classified as an SDG-related paper, that it is relevant to policymakers. But that's not necessarily the case. Because even though the SDG papers account for less than 30% of papers and they account for 60+% of policy citations, the vast majority of these SDG papers are simply not cited in policy. So to what extent are those not cited papers affecting this analysis or affecting the model or affecting our interpretation of the results? So what we needed to do is not just rely on a classification, but figure out another mechanism to filter out the papers that are not relevant to policy. And this is where the second part or the second paper or of the research came about. So what we wanted to do is run the same test, the same parameters, same test, but trying to do it while controlling for policy relevance by making sure that the only papers we're comparing are papers that are relevant to policymakers. So what we did here is found a methodology that was developed by a very good team of scientists, which basically started twinning papers. So that what they did is they would find papers that are very similar to each other and or working on the same discovery, and then they would twin them, and then they would see the differences in their parameters and how that explained different things. In their particular case, so for example, in this paper by Matt Marks and David Sue, they looked at research commercialization. So they want to see which papers ended up becoming, or which research ended up becoming a patent or a spin out or something kind of commercially aspected. So we wanted to do the same kind of aspect. So yes, I said, great, this works perfectly well. Let's see how we can twin research or match papers and then see the differences in the parameters. The problem is that they had a very manual way of twinning these papers. So they wanted to find papers that are published no more than 1 year apart, where the authors are all different, which have been cited at least 5 times, which have been cited where both papers have been cited by a forward paper. So a third paper cites both of them at least. So papers share the citations, at least half of them. And most importantly, you know how you write you write your bibliography, you put your research at the end, but sometimes you cite in parentheses, right? You put them inside the paragraph. So they had to appear in the same inline citation, the same paragraph. So they were cited in the same, and that was a very difficult step. I could not replicate this because I did not have the resources or capability to do this. So I had to innovate. So what did I innovate? I innovated using LLMs. I was lucky that large language models, that natural language processing at the time of my PhD is becoming more available. So that's what we tried to do. So what we did is we took 200,000 research papers that were classified under one SDG, which was SDG 13 climate action. I took the papers between 2016 and 2022. We took their embeddings. So that means we took a pre-trained language model, converted the abstract into a machine-readable format, and then used something called a KNN search, which was basically trying to find the nearest neighbors for this particular abstract. So it takes an abstract, it finds the 10 closest papers to that abstract based on that model's understanding of the paper. And then we said, great, for each of these nearest neighbors, give me the top 10 with a minimum similarity score of 0.8. And then we applied the same kind of filtration, 1 year apart, no common authors, etc., the same one that we saw there. And then we ended up with about 14,000 pairs. So from 200,000, we slimmed down to 14,000 papers, where one paper was cited in policy and one paper was not. So these are two very similar papers based on abstract similarity. One is cited in policy, one is not, published within a year of each other, etc., etc. So this was kind of the data set we tried to use for this particular methodology. And this is just an example of the titles, right? So you can see, paper one, carbon black emissions and associated health impacts in the United States. The model, the language model matched that with quantification of the global and regional impacts of gas flaring on human health. So you can see both of these papers have something to do with health impact of gas flaring. So great. So I assume that as a policymaker working on health impact of gas flaring or working on air pollution or any of these things, I should have probably read both of these papers. Both of these papers were relevant to me as a policymaker when I was making my decision on these things. So what did we do here? So as I mentioned, we took the same parameters from the first paper, right? So number of academic citations, the journal impact, and the H index. I tweaked them a little bit because here, because the papers are matched, I'm able to find the number, and they're cited, one of them is cited in policy documents. I'm able to find the date of the policy document and the date of the paper. So I can extract and just remove any citations the paper receives after the policy date, right? We don't really care how many citations in research that a paper receives after it's been cited in policy, because that's not the question here. The question is, at the time of the policymaker writing the policy, how many citations in academia did the paper receive? So we filtered out anything that was happening after the date of the policy citation. But because it's a smaller data set, we could add more parameters. So we added basically 3 extra parameters that we didn't include in the first study. So the first one was the team's past policy experience. So how many times has the team of paper 1 and the team of paper 2 published papers that were cited in policy before? So this allows us to understand if the team, that what determines if a paper gets cited in policy or not is the team's past policy experience. The second parameter we added was government collaboration. So we read all around in the literature that if you need to work with governments, you need to kind of collaborate with public policy institutes, and that will increase your likelihood of a paper being cited in policy. So you know what, let's test it. So we took all the authors, and if any author had a paper that was, if any author belonged to an institution that was government institution, great. You were collaborating with the government on this research, so we were able to put this into the parameter. And then I added geography. So I just wanted to understand if global north or global south makes a difference, right? If you're an author from a global north university, or if you're an author from a global south university, does that make a difference in your in whether or not the paper gets cited in policy? And here again, we did a regression model, but it's a different regression model because this one we have a paired data. So we had to use something called a paired logistic regression. So this one looks at the differences within two pairs. And then we basically tell the model, hey, given these two pairs that I give you, which one is cited in policy, which one is not cited in policy. And we test based on the model's ability to predict that based on only this information. Just a quick kind of overview of the data. So the papers that within the pairs, so the papers that were cited in policy, so that's oh, actually my legend is wrong here. So sorry, the legend's correct. So yeah, the blue ones are cited in policy. So you'd see that they tended to have more papers, had more early citations. So the papers cited in policy had more citations than the papers not cited in policy. Similarly, you can see here that the blue margins, the distribution is a bit more to the right, which means that the journals tended to be of better quality, which what we saw before. And that they had kind of higher H indexes. The authors of the papers had higher H indexes when they were cited in policy versus not within the pairs. Here you can see that for government collaboration, generally the one you need to be looking at is the government academic line. So you see the two dots where the connect government academic line. You can see that in general, the ones that were cited in policy, there were more aggregate papers of government collaboration cited in policy than not. And the reason I'm showing you this is because you also have to understand the data limitations, because the vast majority of research is not with collaboration governments, right? That's the size of the data set here. So it's important to understand that there's a fundamental difference, that the data is skewed towards purely academic research versus collaborative research. And then again, here we see that the papers cited in policy tended to have more policy experience than the authors of papers cited in policy tend to have more policy experience than those that didn't. Again, with the author geography, the vast majority of papers are global north papers, right? There's more global north authors publishing and being indexed than global south, and that's there's a lot of reasons for that. So, but interestingly here again, we see that global south papers tend to appear more in the not cited category. So you can still see a difference. If you look at the middle bar on both charts, you can see that the orange one is kind of much larger than the blue one in the middle, which means that most of the global south papers were not cited in policy here. Right, so let's look at the results of the model. According to the model, academic citations played the biggest role. So what determines if something would get cited in policy or not is the number of early academic citations. So how would we interpret this result given the context of the research? Given two very similar papers, academic citations increase the likelihood of that paper being cited in policy. But again, we have to keep it within the controls of the experiment, within very highly similar papers, right? So within papers that are highly similar, if you get more early academic citations, you're more likely to get cited in policy. The second biggest factor was media mentions. So if you have media mentions, you're also going to increase your chances of getting picked up in policy. Interestingly, all the rest, you see that dotted line, that's the one line. So the closer you are to that line, the less of an effect that factor plays on whether or not you get cited in policy. So interestingly, the journal impact, the H index, the cumulative policy experience, and even government collaboration played such a small role compared to the other metrics, which I think is very interesting. However, I'll explain why that's a limitation, perhaps in one of the questions later on. But another way to see this is that by far, when comparing the different models, the academic citations played a much bigger role compared to all the other ones, right? This is the explainability and the coefficient, right? So it explained more of why something gets cited in policy, and each unit played or each standard deviation change in that unit played a big role. So it's really, really early academic citations within that context are really important for policy impact. So what do we learn from this experiment? Early citations matter. When media mentions occur, because they're very rare, they're influential. Collaboration with government is less impactful than originally thought. And previous policy experience matters, but up to a certain point. And I want to talk a bit about these two, the two I just mentioned now, right? The collaboration is less impactful, and the previous policy experience doesn't matter. The structure of the data, right? We have an inherent bias or an implicit bias in the data. I'm only looking at policy relevant research, right? So what we're saying here is when you collaborate with government, it doesn't increase your likelihood of citation. However, but the point of collaborating with government is making sure your research is relevant. So is this data set already only includes policy relevant research? Why? Because it's taking a paper that was cited in policy and finding something very similar to it. So both papers are relevant to government, regardless of who authored them. So I would argue that the government collaboration aspect is not that it's not important, is that it's in this particular context of the data, it doesn't play a big role because the main value of you collaborating with government is making sure your research is policy relevant. And in this data set, all our research is policy relevant by virtue of the way we selected it. With regards to previous policy experience, again, these are highly policy relevant research, which means the authors are more likely to have been engaging in policy circles than not. So again, it's not about whether it's not to say that you shouldn't have policy experience, it's to say that within the sphere of policy relevant research, the past experience of authors doesn't matter because they're already in the same race. So think of it like sports, I guess. If everyone is a marathon runner, your sample only includes marathon runners, then yeah, they're more likely to be good runners or in good shape. So that's kind of the way it's the selection bias of the paper. And this is why I think we're moving on to the third chapter, which was that policy relevance really matters. It changes the way that we change that we interpret the data. And this is why we need a better, more scalable approach for measuring or assessing policy impact based on only including policy relevant research. See, the problem of my second chapter is that it's only applicable, only works on a small scale of papers, 200,000. I cannot scale it to 90 million. So it requires a fundamentally different approach to do that. And this is why we're working on with the third chapter, which is to actually train machine learning models based on what is and is not cited using language embeddings. So this is where I am right now in the research. I do not have too many results to share. This is kind of still ongoing, but essentially we've built a machine learning model where it takes the embeddings of a policy cited paper, the embeddings of a not policy cited paper, trains the machine learning model on these things, and then tries to predict whether or not a paper is cited in policy or not, and use that as a benchmark for policy relevance. So we were able to run this model, and we found about 7 million papers that are policy relevant but not cited, which we're using for further analysis on the subject. And this is just to show how the model kind of works and the impacts in general. It's got about an 80% plus, I guess you want to say, depends on different metrics. So, average precision of 80% plus, but differs per field. So different fields have different impacts. But here is where I'm going to say to be continued, because this is, where I've reached currently in my research and where there's much more analysis to be done. So I'll take this opportunity to thank you all for listening. I did want to just take 2 seconds to say that I invited a colleague of mine to this talk. Her name is Elizabeth. She's in the chat. She's doing research on solar energy in Pakistan. So if any of you are working on solar energy in Pakistan, please do reach out to her in the chat because I'm sure there's a way to collaborate. In any case, I'll stop here and open up for questions. So thank you again for your attention.
Okay, great, Basil. Great work, great presentation. And that's indeed a very interesting area to look into, that how the academic indicators that have been considered the gold standards for a long time, they are not very instrumental in getting your paper into the relevant policy document. So definitely this is a very interesting topic to look upon. So, my just one question from you before I open the floor to the participants' questions. Uh, so you come up to the point that academic citation does play a role. So, especially the early citation, how early your paper is cited. So, if this is your main point, then it brings us to the same debate of having more and more paper getting published, more and more citations, and so we are just brought back to that academic so-called what we would call academic tug of war, having more papers, having more citations to let your paper get into some policy document. So the academic tug of war or academic race is also being mapped to the policy relevant race. Isn't what you conclude from your findings?
So I think what I would conclude is if you want to get cited in policy, don't play the game in the default setting or don't play that race in the default setting. Start because if you play it just to get academic citations, what we saw in the first analysis, you're not really going to get anywhere. So before you write a paper, before you do a research project, make sure it's relevant to policy, right? So because the academic citations mattered on the condition that your paper is relevant to policy. That's what we learned in chapter 2. So you need to satisfy that initial condition. You need to say, hey, my research is policy relevant, and then I need to get it kind of into academic citations or into media mentions, because these are the two key factors that play the role here. So that's what I would say is that, yes, you will have the race, but to win that race, you need to kind of start by making sure your research, when we say policy relevant, addresses a policy question, includes a stakeholder, right? So all the literature that we see on how to engage or how to kind of make sure that your research is picked up, do it. Talk to policymakers, talk to stakeholders, talk to government institutes, and make sure your research aligns with their mission objectives or problems, more importantly.
So the point is that you have to make your objective very clear from the right from the start. That if you have to be policy relevant, you have some policy focus in your paper, not just for the purpose of academic citation. So my one more question from you is that you also found that collaborating with the government does not have that much impact. So this result was very much expected. But what do you think? What is the reason that collaborating with government is not very instrumental in getting your policy, in getting your research get into the policy document? What do you think are the reasons for that?
Sure. So I'll start with one key limitation. So there's multiple forms of collaborating with government. Um, Not all of them require co-authorship. So keep in mind that the way we identified in the data set co-authorship was based on so the way we identified government collaboration was based on co-authorship. So I needed to see on each paper the title. So I have the authors, and I wanted to see at least one author being government or affiliated to a government institute. So this is how we measured government collaboration. But this is, I think, a very rare or a very small chunk of the different ways that you can collaborate with governments. For example, even in my data, I can see that there are, acknowledgements, and they sometimes include authors or government authors. And I think um, so this isn't captured, right? But this is another form of collaboration. And then there's all different types of government collaboration that won't be captured in the data, right? If you have a round of stakeholder interviews before you do your research, if you kind of consult or engage with them, you wouldn't necessarily put them as an author. Maybe you wouldn't acknowledge them in the acknowledgements, but you've worked with them. So these two aspects are not captured in this analysis, which means to say that I don't want to say it doesn't matter because I don't know about the other two. So when it comes to co-authoring with a government entity, it doesn't play a role, again, on the condition of equally policy relevant research. So I would argue that it didn't play a role because the research or both papers were already highly relevant to policy. So if you had published, the value of collaborating with the government is to satisfy the initial condition of getting your paper to be policy relevant. But then once you've achieved, you could write a policy relevant paper without including a government co-author, right? You could do that. But ultimately, it helps you achieve that condition. But once you've achieved that condition, there's no real added benefit of working with them. So I guess that the myth we could dispel is, hey, if I collaborate with this government entity, I'm more likely to get cited in there versus not. No, it's going to make your research more relevant, but it's not going to open up new ways for you to get cited in policy.
Okay, great explanation. Okay, so now I would invite some guests here. I would request Dr. Saeed Farooq Shah. He's from KPK. And I will also request Mr. Hussain Ahmed. He's also from KPK. And Mr. Adnan Ahmed from RADS. If they have any questions to Basil, the floor is open to you for any questions.
So this is Adnan. Can I go at it?
Yeah, sure.
Sure. So Basil, thank you. This is very fascinating. But I'm kind of thinking back from a policy point of view. My work has been in actually translating evidence to policy and how that's taken up in Pakistan. So there's a couple of ways, things that are going through my head. First is that if you look at the world, only about 13% of the world lives under democracy, a functional democracy, as economist defines it, which essentially means that policies are made that are directed to the welfare of the people that are being, that are under the jurisdiction of a government. So policies may or may not be actually relevant to the people, and therefore the evidence would probably not be sought out. And then there's work out of the United States that I think it's Brian Kaplan and Bruce Bueno de Mesquita separately, saying that a lot of times when the policy cites literature, they go back and find evidence that suits their policy objectives rather than an exploratory form of way of doing it. So that would actually confirm what you just showed, that a lot of the policy citations are actually those that are multiply referred, because those would be the ones that are actually known more to either lay people or people working in the offices of politicians. So that kind of just goes in line. And I think more comments here than questions.
Oh, thank you so much for these comments. So, I mean, yes, I would agree with most of what you're saying. So I think I'll start with the second one since it's fresher in my mind. Yeah, I mean, this is a key debate. I mean, is it evidence-based policy making or policy-based evidence, right? So, in a lot of cases, you could argue that yes, policymakers find the evidence that suits their agenda. Unfortunately, I don't yet know how we can kind of detect that, at least quantitatively, using the data sets that we have, but it's definitely something that is being discussed widely in the literature. I would add a few kind of just observations from what I've seen on this story. So we also see in policy documents that they a lot of times cite other policy documents. So actually, if anything, I forget the exact ratio now, but a significant portion of the citations within a policy document are other policy documents. So in a way, I think it's useful for two reasons. First, you could argue that these kind of cited policy documents are synthesizing the evidence that was kind of in the first document. So a document kind of synthesizes the evidence, writes a policy document or a policy brief, and then that policy brief is cited by a third document. So in a lot of ways, they're not necessarily using direct knowledge, they're using indirect knowledge from another partner organization, so to speak. So I think that's it might be a factor that affects how we look at these citations, because in the work that I've done, I've only focused on, let's say, a primary citation. So where a policy document cites only a research document and not a policy document citing another policy document that cites a research document. So I think a good chunk of the evidence is coming from between organizations, and that might play a kind of an amplifying role, because what it's doing here is if a paper is cited in the first policy, then it's just kind of basically taken for granted, and then that knowledge is being kind of passed down from institute to institute. I think the paper, one of the two papers originally cited, one of them, I think the science paper by Ian, he argues that during the pandemic, international organizations played that kind of role. So science was cited by the WHO, for example, and then governments would cite the knowledge of the WHO to kind of make their own. So there's this kind of like dynamic as well of kind of policy bodies citing other policy documents. With regards to the democracy question, I don't know. That's a very good question. I mean, I guess the premise here is, do only democracies use science for better policy, or can non-democracies also use science for better policy? I guess the question is so we can decouple the better policy from the science use. So yes, you could make a claim that maybe democracies will want to use science for the outcome of improving kind of societal benefits, but I guess the outcome doesn't matter as much as long as they're using, in both cases, they probably have to use science to justify some policy or the other. But I think it's a very interesting question to explore further, which is, was the science used to create a policy that's better for people or better for, let's say, certain interests or certain groups within a country. So yeah, thank you for that. It's a very, I'm probably going to sit and think about that for a few days. So thank you for sharing that thought.
But just quickly, if I may add, you may want to look at work by Paul Kearney out of University of Stirling. I've used his work quite a bit to help me. He works on evidence to policy work. So his framework, I found it very useful. So maybe that's something you'll consider.
Thank you. I definitely will.
Okay, thank you for just going with your arguments. A question comes in my mind. Basil, do you think a policy has a better chance to success if it cites more policy relevant document?
Ooh, good question.
Wow.
So we've had that debate. I unfortunately don't have the slide here, but essentially one of the kind of images we generated was looking at to what extent governments cite policy relevant research, and you'd see a dichotomy, like a bridge, right? So on one hand, some countries were citing high quality and high policy relevance research, and other countries were citing high quality but low policy relevance research. And that really was like a kind of a puzzle, because you're saying, hold on a minute, are these countries bad or good? Is that a good or bad job? And I don't know, I think it's a judgment call. Some people I talked to, they basically said, no, actually, you want a government to be able to pick up on low policy relevant research, because that means they have the capability to understand kind of less, more technical or more academic literature and use that to inform the policy, as compared to kind of the more only applied research. I would add one thing that, interestingly, in the third aspect, when I shared the kind of the model that was scaled across the entire science, so fields that we normally wouldn't assume are policy relevant, like mathematics, physics, stuff like that. Actually, some of them had high policy relevance and some of them were being cited. And I would say that this mean, and mostly when I looked, kind of zoomed in and said, hey, what is this random paper in math being cited in a policy document? And I noticed a lot of them were methodological papers. So especially like the economics, central banks, they were trying to use kind of pure maths kind of models to kind of, I don't know, I guess, model economic growth or model some policy, some fiscal policy or whatnot. So I think if governments are able to use low quality, or not low quality, sorry, low policy relevance research, it just means that they have in-house the technical capability to understand and implement some very technical or very academically focused research. So again, this is just an opinion, not based on the data or the full analysis, just from my observations as an individual.
Okay. So Dr. Saeed Farooq Shah is here, and he has put a question in the chat box. Sir, do you want to ask this question, or should I read it to Basil? Okay, so basically, Basil, he is asking that sorry, he's just passing a comment that we should also consider other competitors. He was talking about the ML models like random forest to the logistic, and then we will be able to clearly state that which factors are more influential.
Yeah, so 100%, and the third model uses kind of more complex models in the training. I would just say that in the first two models, the reason we used regressions isn't because the objective here wasn't to optimize predictability. I'm not trying to kind of add technical complexity to try to kind of get that extra few percentage points on accuracy or recall. It was more to just kind of get a general idea of explainability. So in the first two models, we went with like a low tech or the lowest possible complexity model because, again, we just wanted a rough idea of the explainability. However, in the third model, yes, definitely we want to maximize predictability because we want to actually capture the policy relevant research. So that is where we're using pretty much as there's a random forests and other kind of models to try to capture, maximize as much as possible the predictive capability of the model. So yeah, thank you for that comment.
Okay, so any other questions from the panelists or any of the attendees here we are having?